Hello friends, in this lecture we are going to solve some problems related to trigonometry for whatever we have studied so far. So I have written down a few questions here, so we will solve all of these in this lecture. So we have 8 questions to solve. So let's begin. So we know the standard values sine pi by 6. Pi by 6 is 30 degree, pi by 3 is 60 degree. So we have to prove that this left hand side, this term is equal to 1. So we can start. um so our left hand side is this term, so we can directly start evaluating this. So 3 sine pi by 6 is 1 by 2, sec pi by 3 is 1 divided by cos pi by 3, and cos pi by 3 is 1. So 1 divided by cos pi by 3 is 1 by 2. So sec pi by 3 would be 2. 2. So it's 2. Next term is sine 5 pi by 6. So we can write it as sine pi minus pi by 6. And cot pi by 4 is 1 divided by tan pi by 4. And tan pi by 4 is tan 45 degrees 1. So our left hand side is 3 minus 4. Sine pi minus x is sine x. So we can write sine pi by 6. Pi minus pi by 6. Sine pi minus pi by 6 is sine pi by 6. Which we can write as 3 minus sine pi by 6 again. So here this sine 30 is half. So this 2 cancels it 2 times. So we have 3 minus 2, which is equal to 1. And this is equal to our right hand side. So this was pretty simple equation. If you remember these basic angles, pi by 6, pi by 3, pi by 4, these angles, then you will be able to solve it. Next is we have to find tan pi 15 degree, but we have studied only 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, and then multiples of pi by 2 or multiples of 90 degrees. So we know these values and other multiples of 90, but we have studied the various formulas like sine or cos, tan of a minus b, a plus b. So if we know a, if we know in terms of b, then we can also find their sum and their difference and even factors of those, like 2 times that. So we have to express 15 in terms of sum or difference of these. So clearly 15 is a small value. We have to pick some difference. So either we can pick 60 or 45, or pick 45 or 30. So here also difference is 15, here also difference is 15. So we can pick one of these. So I will pick 60 and 45. 60 degree minus 45 degree, and tan A minus B is tan A minus tan B in the numerator and divided by 1 plus tan A tan B in the denominator. So we can write it as tan 60 degree minus tan 45 degree divided by 1 plus tan A tan B, tan 60 tan 45. And we know that tan 60 is root 3, tan 45 is 1, this divided by 1 plus root 3. So our answer is root 3 minus 1 divided by root 3 plus 1. So this is the value of tan 15 degree. What if we solve using 45 minus 30? We will get 1 minus tan 30 is 1 by root 3. So 1 minus 1 by root 3, and in the denominator 1 plus 1 by root 3. So root 3 we will simplify, we will get, so if we take these two 30 and 45, we will get 1 minus 1 by root 3 divided by 1 plus 1 by root 3. So this will be root 3 minus 1 divided by root 3 in the numerator, and denominator root 3 plus 1 divided by root 3. So root 3 will get cancelled, and we will be left with root 3 minus 1 divided by root 3 plus 1. So whatever value we pick, we will get the same answer. So I had picked 60 here because 60 does not have this term 1 upon 1 by root 3. So we will save this extra step of cancelling these values. So that's why I picked 60 and 45, so that it's directly we will get the answer. So our third question is to prove this, the left hand side is equal to right hand side. So we know the value of sin x plus y. It's sin x cos y plus cos x sin y, and sin x minus y is sin x cos y minus cos x sin y. So we will expand this, the numerator, sin x cos y plus So first term is tan x. We should keep in mind which form we need to bring it to. So we can make this first term tan x by dividing by cos y, because we need to get rid of cos y, and cos x in the denominator. So it will become sin x divided by cos x, which will be tan x. So we have to divide by cos x cos y. So sin x cos y plus cos x sin y. So we will divide the entire thing with cos x cos y, and denominator also we will divide by cos x cos y. So I will directly write it here. So sin x, or let's write it. So I have divided both the numerator and denominator by cos x cos y. So here this cos x will get cancelled, and cos y will get cancelled, and cos x will remain in the denominator. So we will have sin x by cos x plus, and here this cos x term will go away. So we will have sin y and cos y in the denominator. And sin x by cos x is tan sin x by cos x is tan x. So we can write it. The first term is tan x, second term is tan y. And this is equal to our right hand side. So we can write hence proved. So let's move to our fourth question. So again we have to prove that this left hand side is equal to right hand side. So there are multiple ways to solve this. So we had seen some formula in the end. We have, if we have cos a plus b, or cos x plus y, cos x plus cos y. So we have two kind of equations. One is cos of x plus y, another is cos x plus cos y. So in the end of the lecture we had seen cos x plus cos y is 2 times cos x plus y by 2 multiplied by cos x minus y by 2. But we can use that formula also, or we can, if we don't remember that, we can just expand the two terms, these two terms. So this is cos a plus b, this is cos a minus b. So we can also expand these two terms and we will be able to get the result. Or we can directly use this cos a plus cos b thing. So let's expand these two terms individually. So this cos x plus y is cos x cos y minus sin x sin y. So sin pi by 4 sin x. And the second term is cos pi by 4 cos x plus sin pi by 4 sin x. So this term and this term gets cancelled, and these two terms are same. So we can write 2 times cos pi by 4 cos x, and cos pi by 4 we know is 1 divided by root 2. So 2 times 1 divided by root 2 cos x. This root 2 cancels 2 root 2 times, so we get root 2 cos x, which is equal to our right hand side. And we could have written it, solved it using second method. So this angle is A, this angle is B. So our second method would be, so using this formula, cos x plus so this is second method. So we can directly use this formula. So we'll get 2 times x plus y by 2. So x is this pi by 4 plus x, and y is pi by 4 minus x. So adding these we will get pi by 2, and pi by 2 divided by 2 is pi by 4. So with this formula we would get 2 cos pi by 4 because x plus y by 2 is pi by 4, and then x minus y by 2. So x minus y, pi by 4 terms will get cancelled, and we will get 2x, and divided by 2 is x. So we will directly get this. And again this pi by 4 is root 1 by root 2. So we will get back to this, the same thing. So if you remember this formula, you can use this, or just start from the basic, start breaking terms cos a plus b and then cos a minus b, and we will get the result. So next is, again we have to prove So this is, so we see that this angle, first angle is pi by 4 minus x, second angle is pi by 4 minus y, and in the sine term also we are getting the same pair of angles A and B. So it's of the form of cos A cos B minus sin A sin B, which is the formula for cos A plus B. So we know that cos A plus B is cos A cos B minus sin A sin B. So we are directly given that form. So this term will be equal to cos of A plus B. So here A is pi by 4 minus x. So you need to write the complete thing. I am just writing in brief here. So this is our first angle, and second angle is pi by 4 minus y. So this is our A and this is our B. So this is equal to pi by 4 plus pi by 4, it becomes pi by 2. Then minus x minus y, so we will take minus common, and x plus y. And we know that cos pi by 2 minus x is equal to sin x, and sin pi by 2 minus x is cos x. So we know this thing. So here we have cos pi by 2 minus this term. So it will be equal to sin x plus y. And this is our RHS. So it's a very simple proof. If it would not have clicked you in the first instance that this is directly in the form of cos A cos B minus sin A sin B, you could have expanded these terms, and it would have been a long method, but you'd ultimately get the solution. Or you could write it as we had seen, or you can expand it in terms of cos A plus cos B or sin A plus sin B, the formula we had seen in the later part of previous lecture. But I think this is probably the smallest proof that we can give. So now let's move to our next question. So here we have to use the formula for tan x plus y. So tan x plus y is tan x plus tan y divided by 1 minus tan x tan y, and similarly for tan x minus y is tan x minus tan y divided by 1 plus tan x tan y. So the numerator is tan pi by 4 plus tan x divided by 1 minus tan pi by 4. Tan x. So this was the expansion for numerator, and now we will write the denominator term. Tan pi by 4 is 1, so we will write it as 1 plus tan x divided by 1 minus tan pi by 4 is 1, so 1 minus tan x. So here we have a divided by b and this divided by c divided by d. So we can write it as, so this b terms comes in the denominator, so it is AD divided by BC. Why is it so? No, because we can multiply both numerator and denominator by b. So and also by d. So we can write it this way. We multiplied both numerator and denominator by b. So this b get cancelled here, this d get cancelled here. So in the numerator we have AD and in the denominator we have BC. So here this is A, this is B, this is C, this is D. So we get A divided by B, and this term it goes in the numerator, so it will reverse 1 plus tan x divided by 1 minus tan x. So numerator we have 1 plus tan x multiplied by 1 plus tan x. So 1 plus tan x whole square and denominator we have 1 minus tan x whole square. And this is equal to our right hand side. Hence we have proved it. So let's move to next question. So we have sin n plus 1x, sin n plus 2x plus cos x cos y. So it's in the form of sin x sin y plus cos x cos y, or cos x cos y plus sin x sin y. So it's the formula for, this is the first angle. Let's call it A. N plus 1x is A, n plus 2x is B. So it's in the form of cos A cos B plus sin A sin B, which is the formula for cos A minus B. So our left hand side becomes cos of n plus 1x, this is A, minus B is n plus 2x. So we will expand it. Nx plus x minus nx minus 2x. So this nx term gets cancelled and we have x minus 2x, which is minus x. And cos minus x is same as cos x. And this is equal to our right hand side. So here the main thing is to figure it out that it's directly given in some form we had studied. So it's in the form of cos A cos B plus sin A sin B. So while practicing, you should not just remember the formula that if I am given cos A plus B, then I have to expand cos A cos B minus sin A sin B. But even if you are given the right hand side of that formula that we had studied, you should be able to uh, convert it to left hand side. It's not that you will always be given the left hand side and you will be asked to convert it to expand it to right hand side. So you can either expand or compress. So it can be both ways. So here we are compressing it directly to cos A minus B. But while studying, generally we are told this formula that cos A minus B is this expansion, this term. But you should be able to uh, directly pick out these things and convert it to smaller forms. So now this is our last question for today. So this is sine square 6x minus sine square 4x. So we know that a square minus b square is equal to a plus b multiplied by a minus b. A square minus b square is a plus b, a minus b. So we will write it as sine 6x plus sine 4x multiplied by sine 6x minus sine 4x. And we had studied this formula, what is the value of sine x plus sine y. So sin x plus sin y is 2 times sin x plus y by 2 multiplied by cos x minus y by 2. So the first term becomes 2 times sin 6x plus 4x by 2 multiplied by cos 6x minus 4x by 2. So this is our first term, that sin x plus sin 6x plus sin 4x. So this is our first term. And now the second term is of the form sin x minus sin y. So sin x minus sin y is 2 times cos x plus y by 2. So here x is 6x and y is 4x. multiplied by sine 6x minus 4x by 2. So it becomes 6 plus 4, 10 by 2 is sine 5x. And cos 2x by 2 is cos x. So this is our first term. So we know that sine 2x is equal to 2 times sine x cos x. So we will use this formula here. Sine 2x is 2 times sine x cos y. So we will use this reverse formula actually. So directly we cannot use it. We have 5x terms and then x terms. So we will keep the 5x terms together. Sine 5x cos x sine 5x cos 5x and then sin x cos x. So you should keep an eye on what is the right hand side, so that you are step by step you are moving closer to that solution. So the first, this step was pretty simple, this step was also pretty simple, and this is just the directly comes from previous step. But here you have to see that uh, in the right hand side we have 10x and 2x, and here we have 5x and x. So these terms, these angles are double of these angles, so somehow we need to convert it to 2x. So we are here, so we are given this, and we should head towards, sorry, here it should be x. So we are moving, we have to move from x to 2x, so we need to use the formula for 2x, and it's directly in the form of sine 2x form. So this is how you should proceed towards the solution, and these formula keep come in very handy. You should know what is. So I had said that you can derive sine 2x using sine x plus x, but if you are given this 2 sine x cos x, then if you remember this formula, then you will directly write it, otherwise it may be difficult. So from left hand side you can go to right hand side using multiple ways here, but from right hand side uh, still you can break it as sin x plus sin x plus cos x. So you will see that it's of the form of sin x plus x or sin 2x, but it will not be very intuitive. But if you remember the formula, then it will be very easy. So now you can write it as uh, this is 2 times sine 5x cos 5x, which is equal to sine 10x, and then 2 times sine x cos x is sine 2x. Or I will write sine 2x first because it's in the proof. So this is now equal to right hand side. So hence we can write proved. So these are some of the basic problems which you should solve more of these kinds of problem. In fact, you should solve almost all of the questions of NCERT. So gradually you will memorize all the formula. So in the next lecture, we will study about trigonometric functions, trigonometric equations, principal solution and general solutions of trigonometric equations, and then solve some questions related to trigonometric equations and some more questions for the entire trigonometry, because and that will conclude our trigonometry. So thanks for watching and keep practicing. See you in the next lecture.